Good morning to the five guys of calculus. Since we are off another day, I have decided I am going to go ahead and record a lesson and teach a lesson. You will notice in your notes that I did skip a lesson. We'll come back and do that tomorrow. But for today, I am going to teach lesson 78. It's particle motion, and I figured it would be a not too bad lesson for all of my physics guys to understand. And so I'm going to go ahead and teach lesson 78 today. You will notice down at the bottom that your homework to go along with this recorded lesson, so you're to watch the lesson, take the notes, and then your homework is only to complete numbers 2 and 3 from problem set 78. They go directly along with the lesson I'm about to teach. So I am trying not to make this too bad, and I didn't want to give you a video and a whole set of homework to do. And hopefully with any luck, we'll be back in school tomorrow. Otherwise, there is a chance you could see the previous lesson on video. Okay, so particle motion. Let's look at example 1. And I feel like this will be familiar, like you've seen this, so I don't think it will be too bad for you. A particle moves along the x-axis according to the acceleration function, a of t equals 3t. The velocity when t equals 0 is negative 10, and position when t equals 0 is 6. Find the equation that describes the position of the function as a function of time. And then what is the position when t equals 2? So let's start with what we know. And let's start with the fact that we were given the acceleration function. So we know that a of t is equal to 3t. Our job is to work towards the position function, and then we're given information about velocity and position, which will help us complete those equations. Now, if we know acceleration, what's the first logical step here? And hopefully you are realizing that velocity would be the integral of acceleration, because normally if we have position, the derivative of position is velocity, the derivative of velocity is acceleration. Well, now we're going to reverse that order, of course. So, in order to find velocity, so v of t, we're going to do the integral of acceleration, so the integral of 3t, and then since we're working in terms of t, I'll say dt. So I'm going to go ahead and integrate that. The integral of 3t, add 1 to the power, which will make it t squared, and divide by that new power. So 3/2 t squared. Because this is an indefinite integral, officially we will say plus c. Now, if you go back and read, we were given a little bit of information, and we were told that velocity when t equals 0 is negative 10. Or, in other words, what I'm going to say is that v of 0 is negative 10. And that got a little close there. Sorry about that. So v of 0 is negative 10, which means I can use that information to find my c value. I can plug in 0 for t and set my equation equal to negative 10. And so v of 0 is going to be 3/2 times 0 squared plus c equals negative 10. And so then, based on that information, the 3/2 t squared will cancel, and we will find out that c equals negative 10. And yes, you could have realized that without plugging it in, but just trying to remind you how exactly or why exactly c is negative 10. And so our equation for velocity, v of t, is 3/2 t squared minus 10. And that is our velocity equation. From here, realize that if we know velocity, we can now find position. And so again, we're going to do a similar type step. In order to find position, we need to take the integral of velocity. And for position, I'm going to use, they didn't give it to us, did they? So I'm going to use x of t, which is often used for position. In order to find x of t, we're going to do the integral of velocity. So the integral of 3/2 t squared minus 10, quantity times dt. And so if I go ahead and integrate that, the integral of 3/2 t squared, so add 1 to the power, it's t cubed, divide by that new power. Those 3's will actually cancel. And so I have 1/2 t cubed minus the integral of 10 is 10t. And then officially we have to say plus c. And then if you go back up and look at the problem, we were told that position when t equals 0 is 6. So we can use that information. What I would say is x of 0 equals 6, because when you plug in 0, you get out 6. And so if we plug in that information, x of 0 is 1/2 times 0 cubed minus 10 times 0 plus c, and that should be equaling 6. Well, when all those zeros happen, we know that c is 6. And we can rewrite our equation for x of t. And so we now know that x of t is 1/2 t cubed minus 10t plus 6. Oops. And we have completed one of our two goals, which was the first goal was find the equation that describes the position of the object as a function of time. And so right there, that is what we have done. Our other request was, what is the position when t equals 2? So since we have a position function, we can plug in 2. And so we can find x of 2. So 1/2 times t cubed minus 10 times 2 plus 6. Do the math there. 2 to the third is 8. 8 divided by 2 is 4. 4 minus 20 plus 6. So 10 minus 20, so negative 10. So our position is negative 10 units, is what that says. Now, when we talk, it just asks what is the position when t equals 2. And so negative 10 units is an appropriate response. What does negative 10 units mean when we are talking about along the x-axis? And realize that's going to mean 10 units left of the origin. So I'm going to write, I'm running out of room, 10 left of origin. Okay, just to give you a little idea of what that means. Okay. When you are ready, let's try example 2. A particle moves along the x-axis such the acceleration is a of t equals negative 3t. Its position when t equals 3 is 20, and its velocity t equals 1 is 5. What is the position when t equals 4? Also, at what times is the particle changing directions? So you will notice a very similar problem to last time. Ask a different question at the end. I'm looking at my notes and I have a lot of work here to squeeze in. Easier to do paper pencil than it is digitally, but we'll see what we can do here. So, starting with what we know, and that is the fact that a of t is negative 3t. So I'm going to come way over here to the left. If my acceleration is negative 3t, based on knowing acceleration, we can now find velocity. In order to find velocity, we do the integral of acceleration. So we're doing the integral of negative 3t dt. Similar to last time, just throw in a negative sign. So our velocity equation is going to be negative 3/2 t squared plus c. Now, in order to find our c, if you go back up and read in the problem, we were told that velocity when t equals 1 is 5, which means v of 1 equals 5. It also means, unfortunately, we have just lost that lovely easiness of saying, oh, c is 5. That was because time was 0 earlier. Time is no longer 0, so we're going to actually have to do the math. You can't really skip this step. So I'm going to put in 1 for t and set my equation equal to 5. So negative 3/2 times 1 squared plus c equals 5. So negative 3/2 plus c equals 5. You add 3/2 to 5, and I'm going to say my non-calculator brain says that, okay, this is 6.5, if you will, but going officially, I'm going to make that improper and say 13/2. So we know that c is 13/2, and so we can go back and rewrite our official velocity equation. V of t is negative 3/2 t squared plus 13/2. Okay, moving along. If we know velocity, we can now use velocity to find position. So again, I'm going to call it x of t. So in order to find position, we're going to do the integral of velocity. Negative 3/2 t squared plus 13/2 dt. So the integral of negative 3/2 t squared is going to be negative 1/2 t cubed plus 13/2 t plus c. Okay, this time, if you go back up and look, our given information is that position when t equals 3 is 20. So we know that x of 3 is equal to 20. And we can use that information to find c. Again, we cannot just obviously say that c is 20 because it is no longer at time 0. So negative 1/2 times 3 cubed plus 13/2 times 3 plus c has to equal 20. Okay, 3 cubed, that does say cubed there. Look at the previous step. It's 27. So this is going to be negative 27/2 plus 3 times 13 is going to make this 39/2 plus c equals 20. Well, negative 27/2 plus 39/2 is 12/2. I like that. 12/2 is 6, and 6 plus c is 20. And so we know that c is 14. If c is 14, we can write our position function. I'm going to squeeze it in over here before I go use it. So x of t is negative 1/2 t cubed plus 13/2 t plus 14. Hopefully you are following this lesson well enough that even though that's squished in, you can see it. Okay, so they actually officially never asked us to find the position function, so this is not even one of our answers. But, needless to say, we're going to use it. The question asks, what is the position when t equals 4? So, position when t equals 4 means I am finding x of 4. So, plug that 4 in. Negative 1/2 times 4 cubed plus 13, whoops, I just wrote the wrong thing there. 13 halves times 4 plus 14. So, do some math. 4 cubed is 64 times negative 1/2 is negative 32 plus, the next one I'm looking at that 2 and 4 cancel to be 2. 2 times 13 is 26 plus 14. Negative 32 plus 26 is negative 6. Negative 6 plus 14 is 8. So I'm going to say that x of 4 is 8. And that, of course, is 8 units. And if we're talking about position, and it's a positive 8, that, of course, means it is 8 right of the origin. Okay, so again, we're working on the x-axis, so think in terms of positive and negative appropriately. And I believe we have one other question to answer. And that is, at what time is the particle changing direction? So, particle changing direction. So when the particle changes direction, that means the particle has a brief stop. And at what point does the particle have that brief stop? I'm hoping you're saying it there in the comforts of your own home. And that is when the velocity is 0. Okay? And so when the velocity is 0, so we're going to take our velocity equation and set it equal to 0. So negative 3 halves. Negative 3 halves what? T squared. Forgot which one I had to go grab. Plus 13 halves equals 0. Subtract the 13 halves to the other side. So negative 3 halves t squared equals negative 13 halves. I would multiply by the reciprocal. So if I multiply by the reciprocal of negative 3 halves, I'm multiplying by negative 2/3. And so then t squared becomes 13/3. If t squared is 13/3, then we have to take the square root. And we know that t is plus or minus the square root of 13/3. Okay. That is example 2. And lastly, we're going to look at example 3. So if you start looking at example 3, a particle moves along the x-axis so that its velocity at time t is given by v of t equals 1 over t for t greater than 0. And its position is 5 when t equals 2. Find the time when the particle is 10 units to the right of the origin. Okay, let's start with what we know. And what we know is that velocity is 1 over t. So v of t, excuse me, is 1 over t. Okay, so we are given position information, and we're asked something about position at the end. So in order to find position, we know that position is the integral of velocity. So we're doing the integral of 1 over t dt. And special integral, what is the integral of 1 over t? And that is the natural log of t. Of course, plus c. We are then provided with the information that its position is 5 when t equals 2. So I'm going to write that as x of 2 equals 5. Plug it in. Natural log of 2 plus c equals 5. If we subtract the natural log of 2 over, we're going to know that c is 5 minus the natural log of 2. And yes, that is the constant we will use. This is something where you'd always prefer to leave it an exact constant as opposed to going a decimal. So for my position function, I'm going to say x of t is the natural log of t plus 5 minus the natural log of 2. And that is my position formula. Now, the directions asked us, I was thinking two things, just one thing. Find the time when the particle is 10 units to the right of the origin. So what are we trying to do? Trying to find the time when the particle is 10 units to the right. So we are trying to find when x of t equals positive 10. So take your position formula and set it equal to 10. Natural log of t plus 5 minus the natural log of 2 equals 10. If we are working to solve for t, we're going to get t by itself. So I'm going to keep natural log of t on the left. On the right, I already have 10. I'm going to subtract over 5 and add over the natural log of 2. Clean that up a little bit. Natural log of t is equal to 5 plus the natural log of 2. How do we solve for t here? I would call this a left, right, middle. Remember, natural log is base e. And so if we think left, right, middle, then we can rewrite this equation as e to the 5 plus natural log of 2 equals t. Now, assuming if a calculator is not allowed on this problem, then you're done right there. T is that mystical value of e to the 5 plus natural log of 2. If you are allowed a calculator, then you can plug it in a calculator, and t is approximately 296.8263 is what I have written down for 4 decimal places. And I don't believe we were given a time or a units for time. So I'm just going to leave it as that. You could say 296.8263 units, whether it be seconds, minutes, hours, but we don't know what that was. So I'm going to leave it as that. Okay? Okay. On that note, I think I'm done. Okay? Again, your homework is only to do question numbers 2 and 3 from problem set 78. You do not need to do the entire 25 problems like normal. So hopefully you've listened to this video. Those 2 problems go directly with what we've just been doing, so should be on the right track there. And hopefully I will see you tomorrow, Friday, in school.